Welcome to Dr. Jed's Continuing Calculus video series. Today's lesson is section 5.4 from Rogowski, the Fundamental Theorem of Calculus, take 2. We've already learned the fundamental theorem. This is just another way of looking at the same thing. So first we'll go over the rules of what we're talking about, and then we'll do some examples. Since we already know the fundamental theorem, today's lesson should hopefully be pretty easy. So this is what we learned before. This is the fundamental theorem. The integral, or area, underneath f of t here, from x equals a to x equals b, is the antiderivative at b minus the antiderivative at a. And that's what this says. Capital F is the antiderivative of little f, so the derivative of cap f is little f. Now, that is the fundamental theorem. But what we're going to do now is we're going to take the derivative of this. Now the thing is, these are constants, so that's just a number. So taking the derivative of a number is 0. But what if one of those were at x? Or maybe both were related to x? That's what we're going to study. So, here it is. The derivative of that integral, where this one's still just some number a, and that one's x. Well, we know what this is. This integral is the antiderivative at x minus the antiderivative at a. So we take the derivative, we just do that first, and then take the derivative. The derivative of this is going to be the derivative of f, so f prime, at x. I'm going to invoke the chain rule here, because that's an x, it's times the derivative of x. The derivative of x is just 1. Then minus the antiderivative's derivative at a, times, and now the derivative of a is a number, so the derivative is 0. So that's 0 times something, that goes away. 1 times something is just that something, and that something is the original function at x now. So the derivative with respect to x of the integral from a to x of f of t dt is f of x. Let's try it. What's the derivative? I'm going to change this down here to a 1, just because I feel like it. The integral from 1, excuse me, 1 to x of t squared cosine of t dt. What's the derivative of that? Well, we find the antiderivative here minus the antiderivative here. Take the derivative with respect to x. There's so many derivative words in there. But we take the derivative of the antiderivative, gives us the function. And we get x squared cosine x. No plus c. A general antiderivative has a plus c, but we're taking derivatives of that. And plus c, the derivative of plus c, is 0. Let's do a messier one. So this next one, and again, I don't want an a down there. This time let's put a 3 there, just because we can. So, this is the integral from 3 to x squared of e to the t cubed plus 1 dt. That's not something where we know what the antiderivative is, but we don't care. Let's do this a little more formally than the last one. The last one fit the rule very well. This one, a little less so. So this is the derivative with respect to x of, let's call it the antiderivative. The antiderivative at x squared minus the antiderivative at 3. Because that's what the fundamental theorem of calculus says. Now let's take the derivative of this. The derivative of the antiderivative at x squared times, now this is the chain rule, we take the derivative of the inside, minus the antiderivative's derivative at 3 times, by the chain rule, the derivative of 3 is 0. That's all 0. Cap f prime is just this. So we put an x squared in here. What do we get? E to the, well, it's not e to the x squared. It's t is x squared. So it's x squared cubed plus 1 times 2x. That's 0, so we don't worry about that. And I will rewrite this that way. See, when this is not an x, it gets messier, but it's still pretty straightforward. What happens if it's down here, if there's an x down here? Well, then we're going to have some over here too. So let's do an example like that. Take the derivative of this integral, the integral from x to 2x of t squared plus t dt. Now this integral is actually not as convoluted as you might think. When you get to calculus 3, multivariable calculus, and you're integrating in two different directions, the second integral often has x's on the top and the bottom of the integrand. So this is the derivative of the antiderivative, and I'll just keep using cap f at 2x minus cap f at x. So that is cap f prime at 2x times the derivative of 2x minus cap f prime of x times the derivative of x. That times 1 is kind of silly, but it's there. So this is f of 2x times 2 minus f of x. Plug 2x in here. So it's not 2x, it's not 2x, it's 2x squared. So 2x squared, 2x times 2x is 4x squared plus 2x times 2. We don't want to forget that times 2, it comes from the chain rule. Minus f of x. F of x is just that with x's in it. And if I did that, I'd be wrong. Why am I wrong? Because all of that's being subtracted, so all of it should be subtracted. This is not simplified. It's got x squared, it's got x's. We should rewrite it so it looks nicer. I have for 8x squareds there minus 1, that's 7x squareds. I have 4x's minus 1 is 3x's. That's it. Clearly you can imagine the functions could get more complicated. I could have almost anything I want right here, and even here. But the formula, the method, takes care of it. And it's actually, once you get used to it, not too bad. That's actually the entire section, and that's all for today. Until next time, this is Dr. Jed.